This is the Module 5 review for Math 990. So we're just going to kind of look through some of these. Let's look at this first one. So we have 5a cubed minus 2a squared plus 2a minus 7 plus this. Now what we're really doing, since we're adding, none of the signs are going to change. But what we're really doing is it's like we're going to add up, okay, how many a cubes do we have? Well, we have 5a cubes here. We have we're adding 7a cubes there. And so total, we're going to have 12a cubes. Make sure you don't change the exponents, because when you're combining like terms, we're not multiplying, so the exponents don't get changed. So if you think of it like that you're just kind of counting up how many of each type you have, that can help. So you're minusing 2a squareds and then minusing 9 more a squareds. So total, we're going to minus 11a squareds. We're adding 2 a's. We're going to minus 8 a's. And so if we're up 2, we go down 8, we'll be down 6 a's. And then minus 7 plus 5, we end up with minus 2. So we can double check that. 5a cubes and 7a cubes, we got 12. Negative 2 minus 9, we got negative 11. Positive 2 minus 8, we got negative 6. And then negative 7 plus 5, we got minus 2. Notice in that I'm just combining the coefficients. The a cubed or the a squared is just something that follows along. Okay, let's look at number 2. This one can be a very frequently missed problem. And the reason is because this squared, it's telling us there are two 9w minus 7s. So we'll have 9w minus 7 times another 9w minus 7. So I would recommend getting in the habit when you have a binomial squared or a trinomial, whatever it is squared, write it out twice so that you remember to FOIL it out. You multiply all the parts. So we'll have 9w times 9w first, which gives us, we times 9 times 9 is 81. Now in this case, we are timesing, so the exponents will change. So w times w gives us w squared. We add the exponents when we multiply. Then 9w times negative 7 gives us negative 7 times 9 is negative 63w. Negative 7 times 9, again, negative 63w. Negative 7 times negative 7 gives us a positive 49. Now we want to look, can we combine any like terms? Well, if you look here, we've got those two. So we'll still have 81w squared. That's not a like term with w, and so we can't combine them, but we can combine these two. So we'll get negative 126w and then plus 49. So just keep track, if you're multiplying, that's when you can combine things and they become bigger. But when you're adding and subtracting, you can only combine like terms. K3, we're not going to do every single one, but these all have ones I'd like to do. So any number to the 0, even if it's a variable, no matter what it is just 1. So this is just like saying 5 times 1, or just 5. Okay. Now, it might be tempting to think the whole thing is 1, but it's not, because only the y is to the 0. So make sure you be careful with that. Combine like terms, I'm going to skip that one, but kind of the same thing. You might want to underline as you go, so you kind of get the same ones. There's no other x to the 4th, so you write that down and cross it out. And then negative 3x cubed, combine that with this one. Once that's done, cross those out, and so on. Okay, let's look at 5. I know this is one people will have questions on. So whenever we have a fraction to a negative exponent, what we can do is we can flip the fraction. So the denominator goes to the numerator and the numerator goes to the denominator, and then that exponent becomes positive. So what's going to happen is a cubed, b to the 4th, was previously on the bottom. It'll now be on the top. And then a to the 4th, b squared is now on the bottom. And now instead of being to the negative fourth power, this will be to the positive fourth power. So before we go any further, I'm going to simplify inside the parentheses. So before we add in this extra 4, I think it'll be a lot easier. So we can see we have a cubed and a to the fourth. So one way you can even do this is if you're not very comfortable with these, you can write it out. So you can say a times a times a, and then 4b's over now 4a's and 2b's. And this is all to the fourth power. So now we can cancel them. We can say, okay, those cancel each other, those cancel each other, those cancel each other. And let's just do this from the end. And those cancel each other. So I can see left on the numerator or the top, I've got just b squared. And in the denominator, I've got a. So notice it's like I subtracted. And that's exactly what I'm doing. So 4 minus 2, I would just have those 2 b's on top. And on the bottom, I could just subtract those 3 a's, and I had an a left on the bottom. Okay, so now it's a little bit simplified. So now let's deal with the 4 exponent. So what that's going to do is it's got to go to everything in the parentheses. So we'll have b squared to the fourth over a to the fourth. So b squared to the fourth, we have 2 raised to the 4 is going to be 8. So we get b to the 8th over a to the fourth. And that's going to be our final answer. Okay, 6 and 7. So on 6, what I would do is I would cross cancel. If you haven't cross canceled up to this point, it's time to learn how, because cross canceling here will make your life 10 times easier. So first, I'm going to look at the x's. So numbers that are either up and down, so numerator and denominator, or diagonal from each other can be canceled out. So I can see 7 of those x's will cancel out and leave me with just x squared left there. With the y's, all of those will cancel and I'll just be left with y to the 1, or just y. Okay, next, let's do numbers. I can see right away I've got 11 with just a 1 left. That's beautiful. So 11 divided by 11 is 1. 55 divided by 11 is 5. 6, that's not quite as nice, but still good. We can divide by 3. So now we're going to have 3x squared on top over just y on the bottom times just 5 in the numerator of the next one. And oops, I didn't cancel that out. That will be 7 times 7. Okay, so let's make sure we have everything left that we needed to. We've got that x squared and the y, 5 and the 7, 3 and the 1. And now we just multiply straight across the top. So 3x squared times 5 is 15x squared. And then y times 7 is just 7y. Now another way to do this problem is just like what we did on the previous one, where you can write all the x's out, all the y's out. You can even write these in factored form. So you can kind of put it together and be like, okay, 2 times 3 and 55 is 5 times 11. And then write out your 9x's here and then your 4y's here. And then do the same thing on the bottom. And that might be an easier way to cancel out, and it's just as good. So anyway, a couple different ways to do that. This one will be really similar. You'll just need to flip it. So I'm going to leave that one for you. I'm going to leave 7, 8, I'm going to leave 9. Hopefully you see that and you say, oh, it's squared. So I'm going to write it out as 5x plus 1/5 and then 5x plus 1/5 so that you remember to FOIL it. First, outer, inner, last. If you're uncomfortable with fractions, get your calculator out and use it. If you don't have a calculator that can do fractions, email me. I've got some great recommendations that are only like $10 to $15. Okay, 10. 10's another one. If you want, you can kind of simplify it first. So 2 times 5. See, I myself don't want to write out 10 x's and 18 y's. So I would recommend, and especially in the interest of time, not doing that. So we can do this the subtraction way. We know 5 of those x's will cancel out with 10 of those. So we can just say, okay, 10 minus 5, and then y to the 18 minus 7, because those are going to cancel out, and then just over 2 times 13. So 2's cancel, oops. So I'm left with then 5. 10 minus 5 is just 5, so x to the 5th. 18 minus 7 is 11, so y to the 11th all over 13. So we're kind of doing the same thing. We're just basically getting rid of the extras and the things that will cancel out. So that would be our final answer there. Okay. I'm going to leave this one to you because with my writing tool I can't select those, but if you're confused on that one, just reach out. K-12, we've actually done problems like this, so I am going to leave this one to you, but just know when you substitute in, make sure you use parentheses, especially with the negatives. This is something you can check in your calculator, so I would recommend doing that as well. Okay, 13, this is a new one, so let's look at this one. We need to multiply the 6x squared in, so we're going to multiply it to all 3 terms. It might be easier, if you're feeling confused on this, to write, okay, 6x squared times 4x squared minus 6x squared times 4x, or you could have put plus and then make this negative, your choice, minus 6x squared times 5. Okay, let's just make sure I wrote that out right. I always like to double check when I'm taking it out like this. Now you're just going to multiply the numbers together first. So 6 and 4 gives me 24. And then x squared times x squared. Remember when you're multiplying and the base is the same, like they both have that same x, you're just going to add the exponents. So this is multiplying only. That's why we can combine them, because we're multiplying. Minus 6 times 4 is 24. X squared times x to the 1 is x cubed minus 30x squared. Now can we combine any of these at this point? We just combine other ones, and these two are different. The answer is no, because we're adding and subtracting, and when they are not like terms, they're not to the same power, we cannot combine them. This case we could combine because we're multiplying. So when you're multiplying or dividing, you can combine them, but adding and subtracting you can't because they're not like terms. So in this one, this would be your final answer. Okay. This one, let's go ahead and do this one. It's one of those that's small, but I could see it being confusing. To the -1. So we have a to the -2 times -1 gives us a squared. B to the 3rd to the -1 gives us b to the -3. Now our answers need to be written with only positive exponents. And so I'm assuming that on this one it is as well, even though it doesn't say it. And so since this is b to the -3, it will need to go down. So a squared over b cubed would be our final answer. Okay, the speed of light is 3 times 10 to the 8th. If a star is, what is that, trillion? 6,900,000,000,000? Let's see, that's millions, billions, yeah, trillions. How many seconds does it take light to travel from Earth to the star? Okay, well notice this is in meters, right? Actually, first, let's go ahead and write this in scientific notation. I'm about out of time, so I'm going to have to do this fast. So 3, 6, 9, 12. So 6.9 times 10 to the 12th. So since this is meters, we want to find out seconds. We're going to divide by this 3 times 10 to the 8th. So we'll do this kind of similar to what we just did in some of those others. We'll do 6.9 divided by 3, which is 2.3, And then 10 to the 12th by 10 to the 8th, since they're the same, we just subtract the exponent, so times 10 to the 4th, and that's it.